Okay, so today, Math 7, we're talking about probability. So probability is just trying to describe the chance of something happening. Sometimes this is done with percentages, like the chance of rain today is 70%. You could do it with decimals. Today we're going to go with fractions. So the way we're going to create fractions today is for the bottom of the fraction, figure out the number of possible things that could happen. On top, figure out the number of things that are desired by some sort of a story that you're going to be told by me now and by the book for the homework. So if I tell you we're going to flip a coin, make a fraction. When you flip a coin, you have to contemplate how many possible things could happen. And the answer is 2. You can get a head, you can get a tail. It's 2 options on a normal coin. If I'm telling you I want that coin to come up heads, that is the one desired choice out of those 2. The probability of a head would be a half. Let me skip this one. Let me go to the dice for a second. So think about rolling a die. You have to first consider how many options are there. We're talking about a standard die. We're not playing one of those crazy games with 24-sided dice or something. If you roll a standard die, you've got 1, 2, 3, 4, 5, 6. There's 6 possible things that could happen with that when you roll it. So bottom, possible, 6. On top, I'm saying I want you to roll a 4. That is one outcome out of 4. Out of 6, excuse me. So 1/6 is that probability. If I go decks of cards, first thing you've got to do is know how many cards there are in a deck of cards. We're going to assume the jokers are out. We're just playing with what's called a standard deck. We've got ace, king, queen, jack, and numbers like 2 through 10. So in a deck of cards like that, there's 52 cards. So if I tell you to pick a face card, we're going out of 52. I tell you to pick a heart, we're out of 52. I'm telling you to pick a red card, we could go out of 52. I'm telling you to pick the 5 of clubs, we're taking that out of 52. Anything with the deck of cards, you could discount it out of 52. So there's 52 possible cards in the deck that you could pull. On top, all the tops are going to be different because there's a different count on all these different scenarios that I gave you there. I'll just sort of go out of order. I'll do these in the order that I choose. So if we go to pick the 5 of clubs, you'd have to ask yourself, in a deck of cards, how many 5 of clubs are there? And the answer is there is 1. There is 1 5 of clubs. There's a hearts, there's a diamonds, there's a spades, there's a clubs. There's 4 different kinds of 5s in the deck, but there's only 1 5 of clubs. If I had asked you to pick a 5, now we'd have 4 choices out of 52, because there's the 4 cards I just described a second ago. If I told you to pick a heart, okay, the hearts are one of the suits, or what they're called in the deck of cards. So the hearts, there's an ace, a king, a queen, a jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. There's no 1s in decks of cards. That's usually what the aces are. There's 13 different hearts in that deck. So 13 out of 52 could be your hearts. If I ask you to pick a red card would be 26 possibles, because 13 hearts are red. There's also 13 diamonds that are red. The spades are black, the clubs are black. If you haven't played a lot of cards in your life, maybe I'm confusing you. Good news is there's no homework questions about cards. So if you're not familiar with cards, life will go on just fine. If we go to pick a face card, if I ask you to consider how many cards are face cards, a lot of people will say 16, and that's wrong. People will say there's 4 queens, there's 4 kings, there's 4 jacks, there's 4 aces. That's 16 cards that are face cards. If we were here, we'd interact on that. I'd get the answer teased out of you eventually. Aces aren't face cards. Aces aren't face cards because aces don't have faces on the cards. Like, there's not a picture of a person on it. Face cards have faces on them. Kings have faces, queens have faces, jacks have faces. Aces, while special cards in a lot of games, they're not face cards. So we'd have 12 face cards. There's 4 kings, 4 queens, 4 jacks. There's 12 out of 52. So that's the basic idea of probability. At which point, if we were live, I'd see if anybody had a question, and somebody would surely ask the question, should we reduce? And I would hope by now we know the answer to that is always yes. We always want to reduce our fractions. So a half is as good as it gets. 1/6 is as good as it gets. The 1 over 52 before was as good as it gets, but I've changed that. The other of these can reduce. So if we go to reduce this, this would be a half, which leads me to tell you there's a whole other way you could have thought about this question. We could have thought about there being 52 possible outcomes and 26 of them being red and reducing, which we did. You could have also thought a different way. There's reds, there's also black. That's it. Okay, so in another sense for this question, there are two choices, one of which is red. We could have maybe gone straight to that answer if we did that. Likewise back on the hearts. We could have gone 13 out of 52. We can reduce it. We can get a fourth by reducing it. But realistically at the beginning we could have thought, okay, there's 4 choices. Hearts, diamonds, clubs, spades. There's 4 choices. Hearts is one of them and gone straight to the 1/4. Picking a 5. We could reduce this to 1/13th. Or we could have directly thought about the 13ths. 5 is one kind of card. You also have 6, 7, 8, 9, 10, 4, 3, 2, ace, king, queen, jack. There's 13 types of cards. 5 is one of those types out of 13. We could have gone straight there. Likewise, face cards is 3 out of 13. We could have thought to ourselves, again, there's 13 kinds of cards when I just counted the 13. And then king, queen, jack, 3 out of 13. The book won't do any of this because all of this is like questions that could maybe lead you to a world of gambling, maybe is why they don't want to do that. I don't know. There's a lot of gameplay with dice and cards and things like that, but there's a lot of gambling in the world going on too. So the book's going to go all toward pure innocent questions. So they're going to tell you things like, we're going to give you a bunch of marbles. There's 5 blue marbles, 7 red marbles, 7 white marbles. What's the chance that you would pick a blue marble out of a bag if we blindfolded you and had you do that? So you'd have to figure out the bottom is the total possible amount of stuff. There's 5 plus 6 plus 7, there's 18 marbles. So every question, you could start off putting stuff over 18. For blues, you go with the 5. For reds, you go with 6. For white, you go with 7s. If they ask you about non-white, you'd add up all the ones that aren't white. The ones that aren't white are blues and reds. Blues and reds combined, 5 and 6 makes 11. And if they ask you to pick a green one, that's kind of stupid because there's 0 green ones there. It's just not a thing. So we would go that way. In terms of best answers, 5/18 can't be better. 7/18 can't be better. 11/18 can't be better. This could be better. This is better just as 0. We don't even need a fraction. This reducing 1/3 would be our best answer off of that. So that's probability. Possible stuff, count it. That's on the bottom. Whatever the story desires, that goes on top. Excuse me. Page for this is 328. 328, we'll do the letters A to E and the 1 to 25. And that's it.